Hello and welcome back. We're coming to you from the old transit terminal in the downtown. This used to be the hub of activity for the city, and today's topic is more on graphical displays. So let's begin. This presentation 2.2, and we're going to look at ways and means of describing graphical displays of data. Now this is a brief review of what we did last time. We have here a cumulative distribution for the calculus grades, and we saw this bimodal nature here. Two humps, two cluster points, suggest a lurking variable. It's called bimodal. It's skewed to the right or positive skewed, has a potential outlier, and it suggests there's two cluster points, or two peaks in the data. Hidden variable, two subpopulations. In this case, the lower group had math 30, didn't have math 31, and these people did have math 31, so the entry-level skills was a factor. Now we look at the pulse rates of persons at a website, at a work site. We take a random sample of 80, set up the bin range. This is somewhat arbitrary. We choose the easy, 45, 50, and so on. You go through the minimum, max, and so on. So here's the pulse rates, and you'll notice here there's a tendency for to be two humps here. You wouldn't call this two humps because the numbers are so close. And it's not significantly skewed. It tends to be somewhat symmetrical, even though it's skewed in both directions a little bit. It's called bimodal, two cluster points. This suggests there's a lurking variable. In this case, it's gender, and so we look at the gender as an issue, and we separate them here. For women here we have the bin range and the histogram, and for the men we have a similar bin range and that histogram. You can see they peak at different places, so that's why the two humps in the previous data set. So gender is a lurking variable. And here we have four types of distributions. In this case we have one cluster points, heavily skewed right, and it's a potential outlier on the right. We'll discuss what outliers later. Here we have one major hump. This is somewhat normal, symmetrical, not significantly skewed, and no outliers. And this distribution is said to be U-shaped. This illness hits the old and the young. Two cluster points, bimodal, and a potential outlier, although you wouldn't call this an outlier per se. In this case, there's one major hump. It's a very high peaked. Data is skewed, somewhat left, small skewed. The illness hits the elderly. And now this is what you'd see if you looked at the results of the Super 7 and Law of 649, and you can see there's something deceptive here. And what's deceptive, of course, is the starting point is not zero. You're looking at the tops of them, so these high points are exaggerated simply because we're not looking at the base of zero. So this is ratio data. And this is a graph of nicotine levels, of rather cotinine, which is a derivative of nicotine, of smokers, and you can see that this is extremely skewed right. One wonders where they got this data from. And here's one where you're asked to what's deceptive about this. These are graduates and these are high school maybe, and it's deceptive in the sense that the starting point is 25,000. And the creator's probably trying to make a point there. And now what's deceptive about this histogram? Well, what's deceptive is that this data here is in order, but the January, February, March, April could be pinned on the right hand side, giving it a roughly normal distribution. So we have to take into fact this data here is not ratio data. It is interval data. And now we're going to look at probability. Now when we have a frequency distribution, if we look at the ratio of each number here in this frequency to the total, we get a percentage. And if we look at the diagram, this is the histogram, and the relative frequency is this percentage thing here. This becomes a probability distribution. And you can see here these are now probabilities. So we're now making inferences about the population. Probably x less than 50. Well, 50 is over here, so it's just the sum of these numbers. and they're coming on the screen here, 1.1%, and so on, giving you 66% probability of getting a value x less than 50. And here is the frequency, number of successful drillings, maybe at a well site over a region. And we have the relative frequency distribution, and this is the probability distribution. We can say that the peak here is around 6, so you could say somewhat on average you'd have to do 6 drillings to be assured somewhat of success. The probability of less or equal to 6 drillings is the sum of these probabilities, which is 79%. And one more, this is a probability distribution of relative frequency, and again we have this relates to the number of cars sold per week, and you can see here the likelihood it peaks at 6 again. We can various probabilities, less or equal to 5 cars per week, that's the sum up to this point here, and so some of the probabilities, 37%. And that's the end of presentation 2.2. We ask that you review, once again, take notes as required, and go to 2.3.